In this video, we'll look at a sum to infinity. And the first thing to note with sum to infinity is that it always has to do with geometric progressions because a sum to infinity has got a ratio. The second thing is that that ratio has to be between -1 and 1. And so that will often get you a mark in exam just by stating that. You might also see the word converging, does a sequence that converges. And that just means that it's a sum to infinity and the ratio is between -1 and 1. If I have a ratio between -1 and 1, let's just say half, it doesn't mean that I have to do sum to infinity every time. They could still ask me the sum of 10 terms, or in the example below, which I'll talk about now, the sum to 6 terms, but it means it qualifies for using sum to infinity. I love the sum to infinity formula because it's so nice and bite-sized and manageable. And so let's dive into two worked examples. So I give you the terms 40, 20, and 10. So you can see that the ratio is dividing by 2. How do you write divide by 2 as a ratio? You write it as a half. So the ratio is a half. The first term is 40, and they want the sum of 6 terms. So I just plug it into the formula for the sum of a geometric, and out pops my answer 78,75. Now, if I ask for sum to infinity, a is still 40, the ratio is still a half, and I plug it into the formula and I get 80. And what's basically happening is you'll see questions quite commonly like this. Let's say the distance of this whole bounce was 40 and this whole bounce was 20 and 10 and so on. Eventually, if it goes on for infinity, if it goes on forever, the bounces, because they're the ratios between -1 and 1, typically a fraction, because they end up bouncing so small, so negligible, it's like you're eventually just adding naught each time, 0.000000001, that you can add up all these bounces and get an exact answer. Here's another worked example for you. So remember we talked about the intro to sigma. This just represents the formula. And so I'm starting at 1 and I'm going to sum to infinity. So I'm going to sub in 1, get an answer. I'm going to sub in 2 into this formula, get an answer, and 3 and so forth. I'm going to need to work out the first term. That's just 5/3. And then I'm going to have to work out the ratio. A reminder with ratio, the easiest way to do it is term 2 divided by term 1. And that gave me an answer of 1/3. And I plug this into my calculator, or I do it manually in my brain, and it gives me the answer. So pretty straightforward. The one trick that you might sometimes get is, they say we've dropped a ball. I'm going to just add it to this question that I've done here. I've dropped a ball from 40 meters high and it bounces half as high, and so it's gone 20 up and then 20 down. So the distance of this entire bounce was 40, and then it goes half as high, so it's gone 10 up, 10 down. So the distance of that bounce is 20. And the first dropping it was 40. You can see that from here onwards, it made a really nice series where it's bouncing half as high. But this first one makes it a little bit awkward because it's the same as this, or it could just be some completely unrelated number, but it doesn't fit the mold. And so if you get a case like that where you've got one of the bounces just being a drop or being different from the rest, you can simply work it out as normal, but in your answer you'll just add that back in, and instead of getting 80, you'd end up with an answer of 120 meters. And so that resolves the issue of this awkward unrelated bounce. I hope you found that helpful as an introduction to sum to infinity. If you did, please like this video, subscribe to our channel, and share this with your friends. Thanks.